I got to have a really great conversation recently with two people that are on the code making panel, and they work for the Codes and Standards division of Schneider Electric and for NECA. So for upcoming changes with the National Electrical Code, these people are somebody that you want to listen to. So I think this is a great conversation. Check it out. What's up, my friends? We are at NECA in Chicago this year, and I wanted to sit down with some people that know code far better than I do. So I have two gentlemen here from Schneider Electric. I've got Chad, and from NECA, I've got Kyle. And both of them are involved in codes and standards. So at a very high level, they understand what's happening in code and, you know, kind of what's coming down the pipeline in 2026. So as y'all know, code changes every 3 years, and so there's just new information coming out. So I wanted to give these two gentlemen some time to just tell us about what they think are kind of the most important changes that are going to be coming to you and me out in the field. So welcome.
Oh, great. Thanks for having us. You know, I think that there are so many choices we could pick to have this discussion,
we
right?
sat on a Zoom call for a very long time trying to figure out.
And they're going to be two-day programs that cover all the changes, but we're going to hit, you know, just a small number of really impactful ones for the average electrician.
Yeah.
And I think the first one to start with, arc flash hazard marking, is a really big one because it is a basic fundamental of the electrician's safety as he does his job. And 110.16 is where those requirements are found in the code, and some major upheaval really happened this cycle. We had these limitations where it only applied to equipment that was 1,000 amps or greater. But now they've really removed all of that and really expanded those requirements. Kyle, I know that's important for the electrician, and I know from your members, so let me let you weigh in on that too.
Yeah, you know, it's really, for the longest time, there's been this game with NFPA 70E, which regulates worker safety, and, you know, who enforces that? And that's typically done through OSHA by a complaint and whatnot. And that's where all these requirements for labeling equipment for arc flash for the workers so they know how to protect themselves. Well, now that we have the same language in the National Electrical Code, it becomes an installation requirement. So AHJs, inspectors out there looking at these projects, they're not going to sign off on it until the proper study has been done and the arc flash labels are in place now. And so there is a huge upside to having it as an installation requirement instead of what we call a non-traditional like enforcement document like 70E. You know, the electrical communities used to inspectors, you know, telling them what's right, what's wrong.
Yeah.
And now having that in that category, it helps out a lot from the, not just the worker safety standpoint, but the electrical contractors are always in between, right? You're talking to your customer, you're like, well, technically you should have this marking on here. And all the customer hears is, oh, the study's going to cost me $30,000 or $10,000.
Yeah.
Well, now because it's an installation requirement, it's not optional, or you know, or at least perceived to be optional.
Yeah, and so you were an electrician.
Yep.
To me, like a lot of places around the country, the more electricians that I talk to, there's a huge precedent on understanding the code book, the NEC.
Yeah.
70E, 70B, some people have never heard of it, never touched it, never opened it. What kind of importance do you think that there is on understanding all three of these documents as a single piece of literature, really?
I think it's hugely important. I mean, and I would say that the way that NFPA has evolved those documents now over the last 3 or 4 cycles, they've really emphasized how they work together and support each other, kind of create this electrical safety triangle or stool or whatever term you want to use in order to truly and effectively be safe when you're working around or installing electrical equipment, maintaining it. You really got to comply with all 3 of those. You have to have the understanding of what the rules are in all 3 of those. So
yeah,
very important topics.
Yeah, and just to be clear, you know, one of the things that are impactful here is that it really only applies to other than 1 and 2 family dwellings.
That's right. Okay.
So we don't want to worry all the residential folks out there, but still, it's really important concept. And you know, Kyle said it, but I'll repeat it: that the influence of 70 with 70B and 70E. If you think about the life cycle of an installation, you've got the installation piece, but then you've got the service and maintenance pieces that come beyond that and the protection of the worker. So I think it's really important because the installation has to support safe service and maintenance later, right?
Yeah.
And one of the things that differentiates this is that we have the normal requirements where you include the PPE that's required or the incident energy level. So a lot of locations will say, well, we really only want to know what clothes to wear. We stock our guys with 12 cal and then 40 cal, nothing in between, right? So you can go with those kind of markings, or you can include the incident energy markings. So either one, which works. But I think that that's really sort of like hand in hand with the three documents, I think.
Yeah, and I agree. I think like most electricians that are coming up, they do understand the dangers that they're dealing with. So like the 70E is an easy sell, but a lot of people, I think, feel like 70B only applies to huge facilities that are being maintained. Yeah. They don't think about it as like just regular service calls, and it applies to them.
So now your restaurant with an 800 amp service, your doctor's office with a 600 amp service would need to include this marking, and it has a date of assessment. So what's cool about that is that as an electrician, you show up on site to do work, it's a convenience store or something, you've got to add a new circuit or whatever. You can see how long it's been since someone did that assessment, and then sort of determine whether you need to take more action or not. So yeah.
Okay. I know you guys wanted to talk a little bit about service disconnects as well.
Yeah, so the 2023 language for service disconnects also included a section on emergency disconnects, and this is for 1 and 2 family. And the emergency disconnect piece and the way it interacts with the service disconnect was really clumsy. I mean, I'm not really thinking on the committees or the work that was done. The intent was very, very solid, but it created a lot of confusion, right? So we had sort of opposing requirements. We had things that didn't really mesh with each other very well. If you think about the emergency disconnect in 230.85 was required to be outside, but it didn't necessarily have to be the service disconnect. Okay. And we're so used to the service disconnect being, something that is either outside the building or where the conductors pass through the building, right? So if you have a construction where you have a basement, it could be in the basement, right? If you have a garage, a lot of times you see service equipment in the garage of a 1 and 2 family, but now it's got to be outside, right? And then Kyle, why don't you speak to the marking requirements, because that was just as confusing.
So, I agree with you. Like the 23 language was necessary, and I understand the firefighters associations and groups of the world have a lot of input in electrical code for safety, and this is one of those where they're like, hey, this would help us out tremendously, but it created a lot of issues with service grounding too. I got a ton of questions. Where do we put our grounding electrode terminations? Because do they go in the emergency disconnect, the service disconnect? Are they the same? How do we deal with that? So the changes they made in the 26, where it's like, look, now all the service disconnects just have to be outside. It's going to be marked as your emergency disconnect. The required marking, the exact language, I think, is just emergency disconnect, right? Yeah. So I think it's a step in the right direction to try to make it a little less confusing for those folks out there. For sure.
Yeah, code's confusing enough just to learn, but little intricacies like that, I think that's really huge. And, for fire life safety, to me, that just makes sense for that change to happen.
Well, when you think about the construction, and Kyle mentioned it, so I'm going to piggyback off of that, if it's not the service disconnect, if it's just the emergency disconnect, which the 2023 code allowed, well, now it gets mighty confusing about grounding and bonding.
Yeah.
Right?
Where does that point happen?
Because the device, the disconnect was required to be suitable for use of service equipment, which means it comes with that green screw that we all love to put in, right? And just all this confusing about different ways that could be accomplished. Now, there's going to be some challenges in some of the major metros where they had challenges with an outdoor disconnect anyway. High density, they have a hard time fitting all the meters, much less getting a disconnect too. So those pieces, are going to still be resolved in their local jurisdictions. But for the most part, this clears up a ton of confusion. So from a marking standpoint, what the fire service and first responders want is they want that red background, white letter, emergency on the outdoor. Because you think about this is outdoor equipment, so it's 3R, right? So on the outside of that door or cover, that emergency disconnect label is there so they can find it at the night with a flashlight, right? But the disconnect itself, we already had a requirement in 23070 that says you mark next to the handle, service disconnect. So now those two things don't compete and confuse with each other that they did in the 2023 code. And, I guess lastly on this topic is retrofits. This is one of the painful things, I think, is that retrofits are impacted. So if you replace the service equipment, you now have to comply with this section.
Oh.
Yeah.
Oh.
So, yeah. So, I even think about it, I have a daughter whose house was built in 1930. So her service panel is in the back of a closet. So replacing that now means service disconnect outside.
Drop location, everything.
Everything would change.
How does the code actually put it? Like, what is there a certain delineation of what's considered? Because like if you leave the meter and you leave the riser, but you're just changing a panel, does it cover any of that?
It does.
Okay.
There's great clarification there. So only if you're changing that service panel. So you can change the meter enclosure, the raceway, the service conductors, all of that can be changed without having to upgrade to this. But once you start changing the service panel itself, then you're going to fall in the requirements. So.
That's even worse news, right?
Yeah.
Because that's a minor change that I think a lot of people would be like, oh, as long as I just change the panel, I'm okay. But
yeah. Yeah. So if you're moving from overhead to underground, or, you had a tree pull the mast off the side of the house, you can fix all of that without an issue. But
yeah.
Now I think there's challenges from an electrician standpoint if you move all the wiring outside, because that's a lot of branch circuits to penetrate the outside envelope, right? But it's doable too.
Yeah, it depends too. So I just lived in Massachusetts, lived in Austin, I've lived in Wisconsin, Phoenix, even just coming here to see the zeitgeist of an area of how they wire things. And, here everything's in conduit, even in houses, and the building structures and how all of the services on the outside of buildings, because of the age and the quantity of people living in a structure, is way different. In Austin, it's just kind of small houses everywhere. We got big, large scale houses, but we just don't build as densely and as big, I think, in Austin that y'all do. So like it might actually be a lot easier in certain parts of the country to adhere to this, but I can see places like Massachusetts where it's 200-year-old buildings, like this might really hurt a lot of people.
Well, and for extreme weather, right, that coming in the basement that you commonly see in Massachusetts is really helpful for that, right?
Yeah.
So, yeah.
Well, so the next thing that I had a question about was this whole EVSE receptacle thing. So I see a lot of like TikTokers out there that
Glad you're here for this.
So the story is, electrician goes into Home Depot and sees a receptacle that says EVSE on it with a much higher price point, but they look like the exact same receptacle. And they're like, why the hell would I put this in? Because there's no standard that says that I have to in code. Is that something that's changing?
So that's a good point. Yes, the NEC is going to require that those EV receptacles be listed and rated for that use.
Okay.
Now, this is a case, and Kyle, you may want to comment this, where the code is ahead of the industry in terms of the product standard. So when you look at the standard for receptacles, it doesn't include an EV specific listing, right?
Right.
They're working on it. Right. And a lot of the proposals, the last versions of proposals that I was looking at, they were looking at issues that might result from under torquing the terminations or over torquing the terminations. So they're looking at ways to look at the terminal torque and whether that's impacting this as well.
So just to clarify for knuckleheads like me, there is a code that's being put in place in 2026 that there's not even a UL standard for. So that's the kind of confusing part that a lot of people in my comments are probably going to be like, why the hell would we adhere to that then if there's not even a UL standard?
Well, there is a standard. The standard just doesn't have specific requirements for those applications, right?
But the standard is just the regular receptacle as it is, not with the EVSE.
And so I think what you're seeing, though, is that some manufacturers are already having recommended receptacles for that application. And again, once those standard requirements are done, those may or may not match up. So that's the only risk there. And Kyle, you may want to speak to the fact that what do you do when the code requires something that's not available?
So to touch on that specifically, there's even language in the National Electrical Code that addresses new technology, new things that maybe a new technology is developed between cycles and how an AHJ can use 110.3 to evaluate it and things of that nature. But a lot of local jurisdictions will also have language in their local code that adopts the NEC and say, hey, if there's a new product that's not regulated by the NEC, there's a variance process, or there's a way to get it done. We see that right now, and I think there's only 18 states that have adopted the 2023 code even.
Yeah.
And there's new technology recognized in the 2023 code, like fault managed power as an example, that hasn't been in other editions. And we have NECA contractors that want to install these systems, and the jurisdictions have no idea how to handle it.
Yeah.
There's no rules to follow. So they got to go through the variance process, and then they'll use the 23 NEC as a justification, say, here's the rules for it. And the jurisdictions will go, they usually don't have an issue going down that road. The piece about the product standard versus the NEC and how that whole relationship works, it's a chicken and egg game for sure. Because a lot of times the manufacturers, and rightly so, they don't want to invest in developing a product standard, changing their product lines if the NEC isn't going to allow it. So They wait to see if the NEC is going to allow the use of that product, and then they evolve with it, right?
Yeah. Well, what I like about the NEC is that for upcoming changes, a lot of times they'll give you a date as an informational note or something, and saying that, in 2026.
Or an exception that says, doesn't apply in X until September 1st or whatever.
Yeah, but that helps get the manufacturers in line.
Yep.
It's like, all right, they've put something in there, we got to get up on it.
That's usually the solution that a lot of technical committees, when they're evaluating and going through the change process, that those exceptions or those dates, drop dead dates are a lot of times the solution to give manufacturers the notice. Hey, we want this in the code. You guys got 3 years to get your product standard ready to go, and have a product available for commercial availability, and then go from there.
How many times have you seen something like that get pushed back, like an amendment get made or something, because manufacturers aren't ready? They can't solve a problem in that amount of
that
time.
sounds like a perfect segue into the high frequency GFCIs.
I'm polished, man.
Actually, where I was going, you could definitely use that example. But the other example of that is the medium voltage space.
Yeah.
So the NEC went through a whole sequence of segregating out, creating new articles, because we're seeing more and more customers take power at medium voltage levels. So it's not this utility space. So the listing requirements went into code, and then manufacturers came back, and those dates ended up being pushed out again because they needed more time to get all the testing through the testing labs.
Yeah.
So you can think about that medium voltage space. You're limited in the number of test labs that can actually do certification listing of products. So, Kyle mentions the high frequency GFCI, and that's probably another change to talk about if you're ready to talk about it. But I think, in 210.8, we have an informational note now that points to the high frequency GFCI. And what it is it's a frequency weighted GFCI. So when we think about traditional GFCI products, they were designed around the traditional power of 60 hertz. So, as we looked at the evolution, particularly in the HVAC space, the DOE efficiency rules push them to higher and higher frequencies. So they started with multi-speed motors, and then they evolved as efficiencies went higher to power conversion equipment that gives them variable speed. Yeah. So they went from traditional 60 hertz type waveforms to now high frequency, wide spectrum noise, if you will. And when we think about a GFCI product, the main purpose is to prevent electric shock, right? So that 6 milliamp trip is really set for the human let go threshold. But what we've always known is that threshold changes with frequency. So that same level at, say, 7 kilohertz might be 17 milliamps. Right?
Okay.
So, but a traditional GFCI based around 60 hertz was just a simple adding machine. So if you had 1 milliamp at 60 hertz and 10 milliamps at 1,000 hertz, it read 11 milliamps and it tripped. Okay. So this is why we had this unwanted tripping as the industry was evolving very fast. At first it was just like mini splits, and then it went to, you got variable speed on everything. And so a lot of work has been done in that space, but now HF products have like a weighted differential frequency tripping curve that follows that Dalziel. Because the other thing we don't want to lose sight of is that we were averaging 5 deaths a year with HVAC equipment.
Okay.
So you do need to protect people for high frequency, but you need to follow the curve and it needs to increase based on frequency. And so that's really what the HF does. It was a lot of work by the industry, both from the HVAC side and the GFCI side. And I think it's really important because as efficiency gets proved and pushed harder, we're going to see variable speed, power conversion type, and other products.
Oh, yeah.
Yeah. So, just like the HVAC, and it's slightly less talked about, but we're seeing it with swimming pools.
Yeah.
Where they're using the power conversion or a variable speed drive for the pool pump motors, require GFCI protection.
Yeah.
And you have the same high frequency issue. And I like that you call it unwanted tripping instead of nuisance tripping.
Yeah. Why?
Because our industry is called, GFCIs, AFCIs. It's always been, pushback because of nuisance tripping. But really, the GFCIs in these cases are operating exactly how they're supposed to. They're doing their job.
Yeah.
It's just that the GFCI technology and the technology they're using in the equipment are not compatible yet.
Right.
So, when you hear people calling it nuisance tripping, or they, like a sump pump or a dryer in your basement or something, and it trips a GFCI, it's like, oh, this thing's been nuisance tripping. No, your GFCI has been doing its job. There's something wrong with your sump pump, or there's something wrong with your dryer, or whatever it may be.
Yeah, you're right. Because to think of nuisance tripping, it makes me think that it's not doing its job and it's just
That the
waiting
product
out
is bad. Yeah.
And it's like, no, if it's just not paired together well. So this whole HF GFCI thing seems like a really great thing, because now we understand it's not really a nuisance, that it's an application issue.
Yeah.
And importantly, we can follow that Dalziel curve and provide protection at high frequencies, because it's not enough just to say, well, let's just ignore all high frequency, right? Because then you're going to have people, caught in the electrode threshold again. So I think that that's an important piece. The reason why it seems like a small change to the code, but to include an informational note that references to HF, but in 210.8, I think it's F, right? We had the outdoor outlet requirement, and which is really where HVACs got pulled in. Yeah. And it had a September 1st, 2026 effective date. And that date is upheld. So, that's coming next year. And, I'm glad to say that the industry has got in place a solution that they'll have at scale. So products will be available to tackle that task. And, the other one, Kyle mentioned pool pumps, but the other area that this will impact is electric vehicle charging.
Oh, yeah.
Right, because you got inverters on the car doing a lot of that charging sometimes, and you have the same type of high frequency leakage current. So again, that'll be another area to investigate, particularly if you look at cord and plug connected electric vehicle.
Yeah, the whole GFCI. I remember when these first started coming out, a lot of people were like, "We're just not going to put GFI on it." And it's like, well, it's code, but it's just like every $10 million house you built, these people have this problem constantly. And so that's good to hear that the high frequency solves a lot of problems.
And the other piece I think is interesting in just the broader scope of this is that as the industry did an evaluation across, different platforms, they actually found a lot of product standards that didn't have leakage requirements. Okay. And so, as Schneider Electric, as we've even done internal surveys, we found both, in the appliance world and then the equipment world where, even at 60 hertz, devices were leaking more current to the ground than the GFCI would allow. And so there have been things like UL 101 for appliances that have sort of now aligned their leakage current allowances with the GFCI trip curve. Oh, wow. And so, so there, if you will, there was some cleanup in the industry in regards to leakage current.
When you're talking about 210.8F, another thing that comes up a lot is how people don't realize how broad scope it applies, because it does require an outdoor outlet to be GFCI protected. And this is where especially a lot of your audience that's new to the trade, or apprentices, or even journeyman level that maybe aren't as up to code on some of the stuff that they should be, or code knowledge that they should have. Definitions are so important here.
What is an outlet?
What is an outlet? You ask the average person on the street what an outlet is, they're going to point to a receptacle on the wall. That's not what an outlet is. An outlet is anywhere that you're going to take power for utilization equipment. So hardwired, cord and plug connected, doesn't matter. If it's in that voltage and amperage threshold, it's got to be GFCI protected.
Yeah. Thank you for that input.
Yeah.
Actually, that's really good. The amount of arguments that happen, even in like I have a Discord server where a lot of electricians just sit and talk and share pictures and like, hey, I bought these new tools today, or hey, I'm having this problem. But that's one that happens a lot. Is like, what is actually an outlet? Is a meter an outlet because it's letting out power technically, or is a panel an outlet because it's something you can come in and make modifications and let out power for an outlet? So it's just funny that conversation is like actually a really deep one in our culture.
Oh yeah, so much of our working as an AHJ and even in this role, so many times the solution to code questions lies in the definitions, right?
Yeah.
Definitions and scopes.
Do you think as an AHJ, do you find that there's a lot more electricians, maybe just in your area, that either or that don't know code or that just maybe misunderstand code? What do you find more often?
I would say misunderstand, right? Okay. We take it for granted because it's the world we live and breathe in. So, when you're around code geeks all day long, right? Yeah. All the different scenarios that pop up and all what we call like the gray areas have been vetted, and we have conversations about them all the time. Yeah. So I think a lot of it is, when you're working in the field, you barely have enough time to do the work that you're doing, but then on top of it, being up to snuff on all your code stuff. Yeah. And then even beyond that, to have enough time to go to all these training sessions and different code update classes where you can hear how some of the gray areas are fleshed out, and people come up with solutions for them. It's a challenge. So I would say not because the desire isn't there, but just because the time and the availability isn't there to have be up to snuff on the code.
There's this huge push for every electrician to learn as much code as you can to pass a test.
Yeah. Yep. And
that's that license. It's just cherry pick. When I need it on a job, I might look for something. If you're a service electrician, you run across problems left and right constantly. So you're always in there digging about codes. But I think people that are like very specialized in one area, like only residential new construction, right? They learn their AHJ, the ordinances for the area, what codes are necessary. They don't really need to branch out beyond that. So for me, interestingly enough, just making videos and having to talk about a product and then open the code book and see what it says, and doing that for 10 years, I wouldn't say I'm proficient or like an expert level of code like you guys are, but the only reason I know as much as I know is because I've been cracking the book every single day to talk about it, to make videos, to write articles for, Electrical Contractor magazine, and just make sure that what I'm saying is accurate. And a lot of electricians don't have that same kind of drive or even a need to. So,
yeah, I thought I was pretty code savvy when I was an electrician out in the field, and then I realized how little I knew when I started working as an AHJ. Yeah. And you're around all these folks that have been in the code and at that level for decades. Yeah, it's like, man. So
and it's great talking to people like you, because like even other inspectors like Tim McCloich from Connecticut. Yeah. Dude's solid, really smart, and I can sit down and have lunch with him, and it's like, oh my God, I know nothing, or talking to Mike Holt or somebody, like any of y'all. It's really outstanding too, because some of you, when I speak to you, work for a company where you guys are manufacturing products, so your scope of code is very material based and your understanding, whereas a lot of people are inspectors, so it might not be so material based. It's more like the process of how things are done. So it's really interesting to talk to all of y'all, because not only are you experts and proficient with code, but you have your certain special thing that you probably know a little bit more about than other people. Well, let's close this up with the last one. I think that this was really interesting to hear, but Chapter 7 and Chapter 8. The combination of what's going on there.
Yeah, and everybody that's going to see this and wants to comment, yep, they can yell at me, because the 2026 is available now digitally. Like, you can view the NEC. So, there's been this issue with low voltage or communication data. It spans over this huge umbrella of different installations, but they all utilize the same type of cable, right? Yeah. Category cable. So we would have these discussions in the correlated committee meetings, and it's like, so if I'm installing a communication cable, the customer may use it for communication today, but in 2 weeks they may change it and use it for data. Yeah. I've got two different sections of the code that cover that, right? Chapter 8 covered communications, Chapter 7, Article 725 covered data. Well, which one do I use? Because I don't know what the customer's application is going to be in a month from now. So we're like, well, why do we have two different rules for the same structured cabling? Let's just combine it all together. Well, the unique situation there is that the first step in that is they had to remove the independence of Chapter 8. So, when we talk about the NEC, as long as I can remember, Chapter 8 is operated independent of the rest of the code,
Right.
almost like its own standalone document. So when you have something like that, you have to establish rules within that chapter because you're not relying on a lot of the general requirements in the rest of the code. Well, that took an action by Code Panel 1 during the first draft to remove that independence. And when they did, then now we have all these correlation and redundant requirements that we have to address. I guess the best way to say it is we had 2 months to come up with a solution to merge all of these and remove all the redundancy, but also we couldn't do anything technical because it was outside of the rules that we have for the code development process. So we had to keep the content the same, but just remove redundancies. And that's really what you saw in the 2026 is merging those two limited energy sections. That's what we call it now, is limited energy instead of low voltage or communication or data. It's all under that limited energy umbrella. But then we also looked at what makes sense from a usability standpoint. When I was working in the field, even as an HJ, anytime I got a question on Article 725, I cringed because I'm like, I call it the biggest dumpster fire in the code, right? Like it was just very difficult to navigate, and find out where you're
figure out what chapter the article would be in.
Yes, and what section, what kind, and it really is because there's so many different types of low voltage systems that it applies to. So what we did is we ended up structuring the limited energy requirements very similar to how the traditional under 1,000 volt installation requirements are. So if you look at the two side by side, Article 300 is general requirements for under 1,000 volt installations. Article 720 now is general requirements for just limited energy. Those two articles are very similarly structured, established very similar types of general rules, but they're specific to two different categories of installations. And then we just went down the line and said, okay, we've got Article 240 for overcurrent protection. The closest parallel that we could see in the limited energy is power sources, because the overcurrent protection is inherent into the network switches or the power supplies. So we created an article just for those power supplies. And we did Article 722, which is the cabling requirements, right? And it covers all the different cabling requirements. And that really serves as like the wiring method requirements that we see in Chapter 3, for NM cable or EMT and whatnot. There's a new Article 723 that is just limited energy raceways, cable trays, and cable routing assemblies. Thank you, Chad. Just to serve as a parallel to what we have in Chapter 3. And then you go down, grounding and bonding was pulled out separate for limited energy. There's an Article 750 just for that. Over voltage protection is a new Article 742 just for limited energy, similar parallel to Article 242 for surge protection.
Whoa.
And so on
This
down the
all
line.
makes so much more sense, I think.
Yeah.
It's funny because a lot of people, even in exam prep situations or taking classes, getting ready for an exam, there's always this, don't worry about Chapter 8. It's not even, doesn't apply to anything that we do. So a lot of people just completely ignore it. And it's kind of nice to be able to see it integrated in a clean way where I think this will make people take it a lot more seriously and actually try to learn this stuff.
Well, the history of Chapter 8 being independent went back to the days when you had communications utilities. We call it the Ma and Pa Bell era, right? That's been gone a long time, right? And so one other thing I want Kyle to touch on is why we didn't use low voltage. Why do we use limited energy?
Yes. So I guess even backing up further, you can really blame all of this on Class 4 fault managed power systems. Okay. And in a positive way, because it really forced us to look at how we define these different systems. We traditionally would call communication and data low voltage because it operated at a lower voltage, 48 volts or less or 50 volts or less or whatever. Fault managed power gets lumped into the limited energy world. It uses a category type cable or like a security type cable, but it doesn't protect the system from shock and fire because of the power limitation. It actually can operate up to 450 volts. It's the technology in the transmitter that it sends these pulses 500 to 1,000 a second, and each one has a little bit of power and a data component. And if the receiver does not verify receiving that pulse, it shuts down the circuit with fractions of a second, right? So as soon as there's 3 confirmed lack of a handshake, if you will, it shuts the system down.
Okay.
But it's not low voltage.
Right.
And that impacts, we're coming to find out it not just impacts the rules from a code standpoint, but so many jurisdictions across the country have licensing rules that are based on voltage
classes. Yeah.
So and this system was designed to be installed by a sound and communication technician or a low voltage technician. It's the same type of structured cabling. The equipment fits in their TR room racks, in the communications or data closet. But because of this voltage threshold, a lot of jurisdictions are going to require journeyman wiremen, or they're going to have to change their licensing rules. We've seen it already change in Minnesota. They had to address it, and they have a limited energy license now just because of the Class 4.
If you don't mind me asking, you were speaking on definitions earlier.
Yeah.
Is there a definition that's going to clear this up for limited energy?
So there's several new definitions around the Class 4 fault managed power. I think there's just 6. There's 6 of them alone just on fault managed power. But we also created a new definition for limited energy cable, and it clarifies all of the different systems that fall under that umbrella. So communications, coax, fiber, category or class 2, class 3, and class 4 cabling is all under that limited energy umbrella. And then we modified the limited energy system definition to kind of match what we did with the cabling, but also we used some inspiration from the product standards for fault managed power that say, look, it's not necessarily low voltage, it's that we limit the exposure to shock and fire through the technology instead of just limiting the power supply.
Okay.
So yeah, there's some definitions to support it, and it's going to take a lot of education, going out to these different licensing board meetings and explaining to them what the difference is and why it technically is a safe system similar to a low voltage installation, but it operates at this higher voltage threshold.
Yeah. Well, and one thing that'll help with that, I think, is that parallel numbering structure. Kyle's team, one of the things that they did in that task group was make sure that the numbering for those limited energy articles lines up exactly with general wiring. So it makes it really easy to say, this would be one class of work and this would be a different class of work, and to kind of structure it that way.
Okay.
So I did want to hit him up because that's one of the long-standing things is that everyone called it low voltage.
Yeah.
But then what do you do if it's 450 volts DC with new technology that's just as safe and limits the energy? So I think that's the thing that I think really is interesting here is that the code is trying to adapt very quickly so that it supports new technology today and in the future. There are some things that were kicked out of that.
So if you look at some of the systems that we traditionally lumped in with low voltage or limited energy, power limited class 1 circuits we call them power limited, and they get lumped in with the class 2 and class 3. Yeah. But the power supply is 30 volts and 1,000 volt amperes, 1,000 watts, right? Yeah. That is more than enough power to start a fire. And, we've seen it happen in the inspection community and the circles the groups that we work with on different code panels. Non-power limited fire alarm is another one. Those are, traditional Chapter 3 style wiring methods that you have to use for those. And those don't get installed new anymore, but there's still a lot of legacy systems out there that contractors may have to modify or use code requirements in order to keep those systems going. Network powered communications, broadband communications. There's a low powered and then there's medium powered. Well, low powered falls under that limited energy. Medium power, I think it's got a 250 watt or 500 watt threshold or something to that effect. So you can't lump it in with limited energy. A lot of things that needed to be tweaked. And Chapter 8 didn't go away. It still very much exists. Its scope and its size is shrunk down considerably. Now Chapter 8 is just requirements for communications installations outside and entering the building. So if you've got a facility like a college campus and you want to run communications from one building to another, it would be that's the rules that you would use to govern that. It's really still there for the communications utilities, even though they're not bound by the NEC or they're
Right.
exempt from the NEC, a lot of
up to that D mark,
Yes.
there's still some things we
Correct.
yeah.
and a lot of communications utilities will use the NEC as guidance for their specifications.
Yeah.
Even though they don't have to, it just gives them a benchmark, right?
Well, it's just like utility for us,
Yeah.
We've got the point at which service becomes utility. So I think it's the same thing. It's just wires run up to some kind of point where utility takes over. So I can see that.
Yeah.
Do you want to touch on the EMS stuff a little bit, the PCS, without having a 30-minute? Because I feel like this is a long one.
Well, listen, I've worked so hard in that space, and I really enjoy that space because I think it is also one of those new technologies that's going to be a game changer. But I'll just give you some hints of it. So Article 220, which is where we do our load calculations in the 2023 and older code. So as the code restructures itself to make it easier to use, things are going to move. So some of us that are used to thinking, well, it's always in this location, well, get ready, it's all going to move. But that could be a good thing, right? And so Article 220 is moving to Chapter 120, because it's a general requirement. Well, energy management systems is moving right next to it. So 120 and 130. And the good news is that doesn't change in the 2029 restructuring. So it sits, but it just shows that these two handshake each other so well. And if you can think about what's allowed now with the energy management system that includes a power control system functionality, which simply means that it has monitoring and controls to prevent overload. And that's overload of equipment, conductors, or sources, right? That now that can impact your load calculations for a facility. So it really helps with things like service upgrade avoidance. Let's say you're adding multiple EV chargers to a commercial building, or even several to a residence. As you do that load calculation, oftentimes it would require a service upgrade, right? And that's a hurdle too high for most projects, right?
Yeah.
It just sort of wipes it off the table. Well, this power control system would allow you to stay within your existing service rating and control loads, throttle the chargers up and down to stay within that and not do that service upgrade. So that's one example with adding load. I could give you examples with sources, but it's really a powerful idea. And now we have product standard for it, UL 3141. So it's moving at a really nice pace. So yeah exciting times, because if you're integrating sources and you're integrating load control, and you want to limit export to the utility because they have limits on what they want you to export, this does that, so there's just multiple facets here. Yeah.
The last thing I want to ask you is, I just always feel like we're behind as an industry, and we're trying to just keep up with the products that are changing, standards that are changing, safety requirements because things are happening, and the electrification globally, all the data centers, all the crypto mining facilities, like there's just so much happening. And the standards for y'all every 3 years, there's tons of public input. There's all these changes that happen or don't get to happen. Do you feel like y'all are kind of keeping up with where technological advancement's happening in our industry, or do you feel like it's constantly scrambling to try to keep up with how much things are growing in our industry?
I think it's a little mixture of both. I don't know. One of the things that I do like is the approach we've taken for, let's say, DC, for example, because you mentioned data centers. So DC power is a big topic in data center space today. The NEC has had a multiple cycle now DC task group, and largely what they've sort of focused on is setting the guardrails. So these systems, part of that is if you set guardrails, then you don't necessarily have to have it right in terms of the specifics. And that's kind of what the NEC has done with the 1,000 volts and less, 1,500 volts DC and less, and then over. Because setting those kind of guardrails then means that whether you're operating at plus or minus 700, or you're operating at 800 volts DC, or whatever that case may be, you can fit within those guardrails and apply the code. So I think that's a big piece, is making sure that there's nothing that really keeps the code from applying appropriately. Now, the other piece of that you mentioned, I think goes into product standards. And I think product standards, it's a consensus process. You want to have development requirements that products can be listed to for safety, because from an AHJ standpoint, you really want to lean on the fact that a third-party lab has gone through a lot of testing and evaluation for that. So, Kyle, I'll let you weigh in on that. But I think that's the piece that sometimes it's a slower, because it's a deliberate process. And, sometimes it's your industry groups need a lot of input from a lot of sources to accomplish it.
Yeah.
And the EMS with PCS, the UL 3141 is a classic example. And so to get that out there, there's been outlines of investigation that set out a basic set of requirements, but now the consensus process, there's task groups meeting every other week trying to finish that, right?
With how much that you guys have from like public input that comes in, just as like a round rough estimate, would you say that the changes that get adopted in code every year are fewer than the sheer volume of suggested things changed? Like as a percentage, how many things do you think are suggested every year that actually get integrated?
I don't know if I can put an exact percentage on it, but I think there was, if you look at all the changes from 23 to 26, I think there was 3,800 somewhere, give or take, but that includes all of the little, we need to add a comma here or change this. You broke it into a list instead of a.
And there's a lot of.
Yeah. Gosh, I couldn't even tell you how many public inputs there were. I mean, you could probably find out going on NFPA's website, but it's.
Yeah. Well, I'm sure it's like a funnel though, right?
Yeah.
I'm sure there's a lot of things.
Well, and there's repeat ones too, right?
Yeah,
so you may get 10 public inputs on one topic, and then you take the best ideas from all of them and make new code out of that, right?
Yeah.
As far as the keeping up with technology piece, though, I think our industry is evolving so quickly. The way we utilize electricity as consumers is changing so quickly too. It's hard to keep up because the code making process just takes time, right? And even the smaller product standards or installation standards, you have so many interest groups that you're trying to get to collaborate, and everybody brings up valid points as to why we need to change what we're doing here, change what we're doing there, and it just takes time, slower than the technology that's driving it. So I think we're always going to be a little bit behind the 8 ball, but it's getting better, at least in my opinion.
Yeah, the other thing we'll note, Justin, is that sometimes when we get an influx, it's from a new technology, but what we find is that a lot of the participants in that space also are new to the code. Right. And so sometimes there's a back and forth on both sides. Part of the case may be that the code already covers pieces of this installation and they just don't actually know how to fit the pieces together.
Yeah.
I think, but other times, I think that the code already would permit what they're trying to accomplish. So, I know, Kyle, we mentioned yesterday talking about qualified persons, and we've got that in a few places in the code, and usually it's in a new technology area because we want that sort of reawareness that, if you're working in this space, you're installing something in this space, let's say bidirectional EV charging, for example, you really need to know about that space, right? And not only just be knowledgeable because you work for a company that's developed a charger, but you need to understand how it fits in the code process and, to make sure you don't backfeed the utility. There's lots of safety concerns to address there. So I think that there is that piece as well. And I think we saw that with the limited energy place as we brought a whole new group of really participants to the process that because when it was sort of separated, they had to have their own space and everyone left them alone and whatever. But now with class 4 power and PoE products that they need to be integrated, and then they also need to learn the rest of the code. So it's a little bit of a back and forth there. But I will say that I think the product standards, in many cases are driven by these changes. And so I think that oftentimes they're not actually tied to the same 3-year cycle that the NEC is. So most of the time they can take proposals anytime, right? So that process helps as well, right? But even for the 2029 NEC, we're looking at an April date of next year for public inputs.
Oh, wow.
So
Yeah,
it comes really fast.
Really big changes with that.
Yeah.
Oh man.
So Kyle is still leading a limited energy task group. I'm still leading an energy management task group and a bidirectional power task group. So again, it's recognizing new technology. When we think about the way our code was structured, it was all written around you have a utility supply and then you radially field down to loads, right? Well, what if you've got sources here and sources at this level and that level, and you've got power flow both directions? How does the code really address that? Yeah. And so, that's one of the things that we're going to be working on.
Just to speak to your point about how we're already up against the 2029, the revisions, the public input phase for 2029 opens at the end of this month. So people can start already commenting on the 2026 code that just was released earlier this week. In about 2 weeks, they can say, hey, I don't like this. I want to change it.
Yeah. All right. Perfect. Cool. Well, thank you guys so much. I mean, for me, being a field guy, I feel fortunate to be able to sit and talk to people of your caliber and just the access to be able to answer.
You're too kind. You're way too kind.
Yeah, no, I'm serious. I think a lot of people out there want to know more code. A lot of apprentices, especially, it's super daunting. It's really, it can be overwhelming. But I think having stuff like this, these events, and being able to talk to you guys is a true honor. So thank you.
Thank you.
Glad to do it and appreciate the invite.
So I hope you guys gained something out of that. It's really great for us, field knuckleheads to be able to talk to some people that are much smarter than us, that are involved with this process. So I hope you guys gained something. See you in the next one.